Solving rational equations. Solving rational equations involves the following steps. First, we have to multiply both sides of the equation by the LCD. That means the least common denominator. This will clear out the fractions in the equation. It's very important that you do this step on your paper. Don't try to do it in your head, because you'll more than likely lose something. Then you will end up with an equation that doesn't have any fractions in it. So you'll solve this equation. Then you need to check your answer. Sometimes you will end up with an answer to a solution to your equation that when you go back and check it, it makes the denominator 0, or it makes one of the denominators 0. And if it does, then that means you have to throw it out. You cannot use that for one of your solutions. So let's solve a few equations. First, we have x over x minus 5 minus 1 equals 4. So I need to get rid of my fractions here. I only have one denominator. My denominator is x minus 5. Okay. So I'm going to multiply both sides of my equation here by x minus 5. Well, that means that I have to do it by every term on each side of the equation. When I multiply x minus 5 by my first term, x over x minus 5, my x minus 5s will cancel out because I'll have one in the numerator and one in the denominator. So that will leave me with just an x. Then I have to multiply the negative 1 by my x minus 5. The negative 1 doesn't have anything in the denominator to get rid of, but I still have to multiply it by the x minus 5. So that'll give me minus x plus 5. Then I go to the other side of the equation and I have to multiply the 4 times the x minus 5. So that just involves distributing the 4. So that will give me 4x minus 20. Now, I solve this equation. The x minus the x collect together to leave me with just 5 on the left side of the equation. 5 equals 4x minus 20. So to solve this, I need to add 20 to both sides. So that'll give me 25 equals 4x, and then divide by 4. So 25 over 4 is my solution. Now, I have to check that solution to make sure that it won't make any of the denominators 0. If I put, let's think of it this way. The only number that would make the denominator 0 would be a positive 5. So as long as I get an answer here that is not positive 5, it is okay. Now, I can check it by actually plugging the numbers in. Let me show you how to do that, storing your values in your calculator, because this makes it pretty simple to do. My answer I got is 25 over 4. So I want to type in 25 divided by 4, and then I want to store that for x. Enter. Now I want to type the left side of the equation in. So I have x divided by parentheses x minus 5 minus 1. And what the calculator is going to do is it's going to plug in that 6.25 everywhere it sees an x. So I get the first side of the equation is equal to 4. And then I type in the second side of the equation. On this problem, there's no work to do. But as long as these two numbers here are equal, then you check that solution, and it really is a solution. Now let's look at this one. This is another equation that is a rational equation because it contains fractions. So what I want to do here is, again, multiply to get rid of my fractions. In this problem, what I would have to use to get rid of my fractions is the x times 11x plus 42. So I'm going to multiply that on the left side of the equation. And I'm going to multiply that on the right side of the equation. Let me move my calculator here. 11x plus 42. When I do it on the first side of the equation, that 11x plus 42 will cancel because this one's in the numerator and this one's in the denominator. So that will leave me with x times 3x, which is 3x squared. Now on the other side of the equation, it's the x factors that cancel. So that leaves me with 1 times 11x plus 42. So I have 3x squared equals 11x plus 42. Now this is a quadratic equation. So in order to solve it, I need to get it in standard form, which means I need it set equal to 0, and then I have to solve this. I can solve this by factoring, or I can solve it using the quadratic formula. In this particular case, let me go ahead and do the quadratic formula. A is 3, B is negative 11, and C is negative 42. So x would equal the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So this would be a positive 11, because the opposite of negative 11 is positive 11, plus or minus the square root of negative 11 squared minus 4 times 3 times 42, negative 42, all over 2 times 3. So let's see here. Let's see what that works out to. This will give me an 11 plus or minus the square root of, let's see, negative 11 squared minus 4 times 3 times negative 42. Gives me 625. But what I recognize here is that 625 is a perfect square. So I could have done this problem by factoring. 11 plus or minus 25 over 6. So let's see, 11 plus 25 divided by 6 gives me 6, and 11 minus 25 divided by 6 gives me, what was it, negative 14 over 6, which is negative 7/3. So I have a negative 7/3 and a positive 6. Now if I go back to my original problem, the only numbers that would make the denominator 0 here would be a 0, or a negative 42 over 11. So that means that both of these answers would be solutions. Let's look at one more. Here, in order to get rid of my fractions, I have to multiply by my common denominator. But this common denominator, in my denominators, I have to factor this one. My x squared minus 25 needs to be in its factored form, which is x plus 5 times x minus 5. So anytime you have polynomials down there, you need them in their factored form, even if that means just pulling a common factor out. And when you have that, you can then see what your common denominator is. Your least common denominator is going to be x plus 5 times x minus 5. So we're going to multiply that on each side of the equation. Takes a while to write these out sometimes. Okay, so let's do it by the first term. When I multiply the x plus 5 times the x minus 5 by the x over x plus 5, the x plus 5 factors will cancel. So that will leave me x times x minus 5. Then I have my addition. Then I have x plus 5 times x minus 5 multiplied by 3 over x minus 5. So there the x minus 5s will cancel. So that'll leave me with the 3 times the x plus 5. Now on this other side of the equation, the entire denominator cancels. So that leaves me with just the 50. So I have x squared minus 5x plus 3x plus 15 equals 50. So once again, I have a quadratic equation. I want to get it in standard form. So I combine my x terms together, and I subtract the 50 from both sides. So that's going to be minus 35 for the constant term. Now I can solve this equation by factoring. This factors into x minus 7 times x plus 5. So when I set each factor equal to 0, I get x equals 7, and I get x equals negative 5. Now, I have to check these. If you notice, when I put the negative 5 back in here, if I put negative 5 in for this x, I would have negative 5 plus 5, which would give me a 0 in the denominator. So I would throw out the negative 5, and the only solution I have would be negative 7. Now remember, you can also solve graphically. So let's quickly graph this. To solve graphically, I want to put the left side of the equation in y1. So that's x divided by x plus 5 with the x plus 5 in parentheses, plus 3 divided by x minus 5 with the x minus 5 in parentheses. In y2, I want to put the right side of the equation with the x squared minus 25 in parentheses. I'm going to start with a standard window, and I want to look for where these intersect. There's my first graph, and here's my second graph. It's a little hard to see, but I can see that it looks like they're crossing right here. And if I go to my table, I can look numerically at the solutions and see that when x equals 7, I have the same y values. I also can solve it using the intersect under the trace menu. I just have to move my cursor over to that intersection. Okay. There it is. Enter, enter, enter. There's that same x equals 7.